Well, hello again. This is Ron. Welcome back to Fluids. Today we're going to do another pressure fluid height video. What we're going to do here is find the pressure on a submerged surface. And really then what that's going to give us is the ability to find the force on a submerged surface. So what do we mean by a submerged surface? Well, what if we took a swimming pool, but in the lower corner of the swimming pool we had an inclined plane. Now you'll see some things like this in tanks and maybe with a hinge here, and you might want to know, well, what force would I have to apply to lift that surface? Well, the force you would have to apply would be equal to the force that is being applied by the fluid on the surface. You would just use some statics with some of the forces and some of the moments to figure out what force the water is applying or what force I would have to apply to open the gate. Well, the first thing that's worth mentioning is what's causing this force. And it turns out, as we've seen in previous videos, there are two things causing a force on this gate. The first is there's a whole bunch of water on top of it pushing down. The weight of all this water pushing down is something that applies a force to this surface. Another thing that applies a force to that surface is there's a pressure acting at this point, and at this point, and at this point, and at this point. In fact, there's a pressure triangle acting horizontally where the bottom part of this pressure triangle is acting on the gate. Above this point, the pressure triangle isn't acting on the gate, it's acting on the wall. Well, in fluids we would call the weight of this, let's use this box of water here, we'd call that FV1. And this triangle or trapezoid of water, we would call that FV2. And this horizontal force we would call FH. And we could sum up all those forces and do some statics, and we could get the total force acting on this gate. And that's one way of doing it. But there is a better way, an easier way to find the force on a submerged plane. So I'll draw it again. So we're going to find the force acting on this gate. And there are two things we need to know about that force. The first thing is the amount of the force. Well, actually, three things. The amount, the direction, and the location. In this video, we're going to focus only on the amount and the direction. In fact, in fluid's core, we're going to focus only on the amount and the direction. The location is something that we can do in an advanced fluids course if you like. In the FE review manual, the equation for finding the amount of the force, the direction of the force, and the location of the force are all given, and they're pretty simple equations. So the amount is equal to pressure times area. I bet that doesn't surprise you any. The pressure, which is defined as force over area, pressure times area is equal to force. Well, what pressure? Well, we actually call this P bar for the pressure at the centroid. And the centroid is the centroid of the gate, or the submerged surface. Now, the distance that the centroid is below the surface of the tank, I bet you could come up with this, is z bar. Now, in our previous classes, if I asked you to find p bar, you would probably say, well, it's the pressure above the tank plus gamma z bar. But since the pressure above the tank is the same as the pressure below the tank, all we're focusing on here is just the pressure due to the water. That pressure above and below the tank cancel out, and the force being applied here is going to be just due to the gamma z. So the amount of the force is simply gamma of the water, or specific weight of the water, if it is water, times the depth of the centroid of the submerged surface. So whatever that surface is, its centroid depth below the surface. Boom. That's it. That's the equation for the amount. The direction? Perpendicular to the surface of the plane. So this is a plane. Perpendicular to it is the direction. Now the location. I bet you want to say the location is also at the centroid. It's not. In fact, it is located someplace below. Below means down and to the left in this case, below the centroid. We call that distance here. We call this place that it acts, we call that the center of pressure. And there's an equation that you can find in an FE book of how far below the centroid along the plane the center of pressure is. It's so the location is at the center of pressure. The area of the plane would be some area, because it would be this line times some depth into the paper. Well, what is that distance? I'm not going to put the equation down, but I'll tell you what it has to do with. It has to do with how far this extended line is, the extended line of the surface of the plane to the extended line of the water surface. Now, neither of those are inside the tank. They're outside the tank. We call this distance to the centroid y bar, and we call the distance from that same point all the way down, let me use a different color, all the way down to the center of pressure we call YCP. So it's this distance here is YCP minus y bar, and it has to do with the area of the tank, or the area of the plane, and the moment of inertia of the plane, the area moment of inertia of the plane, I, or I bar. So we're not gonna spend any time on it. The point here, the summary, is that when you have a submerged surface, it has a force acting on it. That force is equal to the pressure at the centroid of the surface times the area of the surface, which is gamma of the fluid times the z bar, the depth of the centroid, times A. So this is P bar, and we needed to have an A out there. So P bar times A is gamma z bar times A. That force will be perpendicular to the surface, and it'll act at the center of pressure, which is someplace down here. All right, well, a quick reminder before I close out this video. The whole purpose of this course is for you to develop a model of understanding of fluid mechanics. That model comes from you processing the principles and being able to explain them to yourself. The first point of access for you to get the information is these videos, but they're not meant to be the last point of access. The last point of access should happen in class or during office hours, where you ask me questions to help you further understand the concepts. So anytime we leave one of these videos, I challenge you to have identified a question that would help you better understand. All right, good enough. Thank you much. See you on the flip side.